Hi, in this video, I'm going to be showing the partial products algorithm for multiplication. I like this algorithm because it breaks the problem into smaller pieces and helps students actually see what's really happening when we multiply. And it also connects to place value and the distributive property, which explains why the method works. Our problem is going to be 12 times 13. The first step is to break the numbers into tens and ones. So 12 is going to be 10 plus 2, and 13 is going to be 10 plus 3. And this helps students see the value of each digit, and then you multiply each part. So you would do 10 times 10 equals 100, and then you would do 10 times 3 equals 30, and then you would do 2 times 10 equals 20. And then you would do 2 times 3 equals 6. These smaller answers are called partial products because these are the little pieces that make up the big answer. Once you add them all up, that is what the big answer becomes. But I'm going to show you how you can also draw an area model to help students see it visually. So we're going to start off with a big rectangle and then make 4 pieces. And you will draw the tens and the 2 and 3. So the 2 plus 10 is the 10 plus 2 would be an easy way to say it, is gonna be the top, and then the side is gonna be 10 plus 3, and then you'll multiply. So 10 times 10 equals 100, and then 10 times 3 is 30, and 10 times 2 is 20, and 3 times 2 is 6. So then you will add them all up once you're done with that. But each small rectangle is one of the partial products, and there are diverse learners in classrooms, so this will help visual learners understand where the numbers are actually coming from. So now we add all the pieces together. So we would do 100 plus 30 plus 20 plus 6 equals 156. Meaning that 12 times 13 is 156. But this is just an easier way to break it down. And this algorithm works because of the distributive property. We're taking the numbers apart and we're multiplying each part and then putting them back together. So we're not actually changing the problem. We are just making it easier to understand. And this also works because of the place value, since the tens and ones each have their own drops. When I learned partial products, it helped me a lot because it slows down the math and you can actually see what the tens are doing and what the ones are doing, and it helps you understand the multiplication instead of just copying down the steps. Because before this strategy, I would just do the steps without actually knowing why they worked, and I feel like that goes for a lot of people. And it helps you understand the math behind it. And that's why I want to use it in my future classroom, because it will help students actually understand multiplication better and how it breaks the problem into smaller pieces. Thank you for watching.